Yogesh, and since this is a distributed tool, Yogesh gets a pop-up on his tool that hey Yogesh, Abhijit has assigned you a piece of work. So Yogesh works on it, and once he is done, in the meantime, Abhijit moves this one to in progress. So these two things are in progress, and one more job to be done today is create a quiz. All right. So once Yogesh is done setting up a URL, he will just move it to done, and as soon as something gets done, the entire team. See, Agile is a team sport. Everybody needs to know what is happening. The moment somebody moves it to done, the pop-up goes to all the team members. One job is complete. All right. How does it help is if my job, say Abhijit's job, conduct session is dependent upon URL. The moment that says pop-up, I say, oh great, now I can conduct my session, do it, and then move it to done. So at the end of the day, I can come and see, all right, what did I plan to do? I plan to do three things. Two of them are done. Oh, I forgot to do the quiz, and I can move this here, do the quiz and move it to done. At times it might happen that I'm not getting a chance to do the quiz. It remains in the backlog. So this is supposed to be on everybody's screens, and screen is just a convenience. So let me switch off this background that I'm using for now. Let me show you what we use in the office. HOD sir, I'm just taking 2 minutes to show the agile tool. We have enough time. The next session is a little short, so we won't run out of time.
Okay, okay, no issue.
Right. So most organizations start, we have this glass board here and we attach post-its to it. So we make three columns. We have two of these boards here. These are called Kanban boards. And everybody is free. They can come stand in front of the board, think about it. Okay, so I don't have work today. So one guy, Abhijit, has one thing in the to-do list and he has not been able to start it. So you can go and say, Abhijit, do you mind if I do this work? Because my work is done. So it's a very extreme team sport. It's based on transparency. Everybody sees what's happening, or maybe somebody can say, hey, I need help. I plan to do three things. One thing is not done. Whoever is free, can you help me? And then that person can come and say, yes, I can help you. And that moves here. All this we do in what is called as Scrum meetings. That's called a stand-up meeting for 15 minutes. The rule is, I mean, it's a self-made rule, no more than 15 minutes. People just say two things. What have I done since yesterday? What I am planning to do today? And what are my roadblocks? So somebody might say, I have a dentist appointment today. That's my roadblock. No problem. It's a human thing. Correct? But as a result, for 15 minutes in a day, no more, everybody, the entire team of 5, 6, 10, up to 10 people figure out that yes, today we have this to do for this entire 2 week sprint, how well we are doing. And then they can immediately exchange tasks and all right. So it's a very, very intensely teamwork driven exercise. Why it's called a stand-up meeting is we don't keep chairs here, because once we keep chairs in the meeting, people sit down and they consume one whole hour. So we just have a stand-up meeting, so people get tired of standing up and then they go back to work after 15 minutes, to be honest. All right. So similarly, these are different swim lanes. The first one is, let's say, first day FDP, second swim lane for second day. Similarly, you can have different projects tracked here. So this is called a Scrum board or a Kanban board. Now the format is exactly the same. The philosophy is little different. Scrum is time boxed. I say that this board is going to be here for 1 week. So all the tasks here either get completed after 1 week, or whatever doesn't get completed. Let's say quiz doesn't get completed, my 1 week is over. I will push it back into backlog for the next sprint, because in the next sprint maybe something more urgent is coming. So just because sprint was in progress doesn't mean it gets priority. That's the whole thing about agile. Every week we revisit our priorities and then we can push it back here. All right. So Scrum is time boxed, that whatever we can finish in the assigned time, 1 week gets finished, because if we don't have a time box, then things will keep going forward by day by day by day. So Scrum says the best way to finish things of time is do not extend the time, and it accept the fact that you will pick up 10 things and you will do only 8. Okay. Kanban works a little differently. Kanban is a scope boxed thing. You create a box around a scope. For example, when I have one thing in progress, I will say I will finish this, and only then I will pick the other one, even if it takes 1 week extra. So good example of a Kanban is, if you go to this car servicing garages, they have this big board there, okay, service board. As and when the cars keep coming in, they start writing the numbers on the board, and they say, okay, this car is just coming, this car is finished, these three cars are under progress. So until the car is serviced, they are not going to pick up a new car by leaving another one halfway serviced. Okay, that's a Kanban board. So it's up to us, depending on the project. You can say I want to do Kanban. That means once I pick up a job, I will finish it before taking something else up, no matter how long it takes. Or if you're doing Scrum, I'll say for me, time is more important. I'll work on this for 2 weeks, then I'll take a step back and see, okay, is there something more important to be done? If yes, this goes back, something else comes first. So there are many free tools for doing things like this. The one Madhu mentioned yesterday, Jira, is one of the best tools, but it is not free. I can share some tools. Do try it out. What we do in our home is we have designed a window. It has three glass panes. The first glass pane is to do, the middle glass pane is doing, and the last glass pane is done. And whatever it is shopping, it is giving the Activa for servicing, it is preparing for something else, school, etc. It makes life very easy for everybody, right? So this is a very short demo, very powerful tool, simple but powerful tool. This is called a Scrum board or a Kanban board. If you can see at the top, it's written, it's called a Kanban framework. So I hope you like that little side note on this. Right, Patel sir. I think that little bit of catch up is done.
Yes, yes. Thank you very much, Abhijit. So we are coming to the last session in this FDP. Uh, so Abhijit is going to do this last session again. So I request Abhijit to start with the uh, second session today, and in continuation with that, we will have the final valedictory session as well after he finishes.
Sure, so thanks very much, sir. I'm sure this is not going to be a very long session. It will be probably 1 hour session. So after that we can do the closing ceremony. But this is a very interesting session, all the same. Can one of you confirm that my deck is visible now?
Yes, sir.
All right, so I'm going to move the slides around a little bit. If you can tell me if the slide changes. Right now I'm on the green blackboard. Can you see the blue slide now?
Yes,
Yes,
sir.
sir.
All right, perfect. So what has happened is the monitor next to me seems to be stuck on one slide. So Yogesh, can you switch off the light behind me? Yes. Behind me. Switch that off. Keep the other one. Yeah, thank you. All right, guys. So welcome back. This is the final practically session of this wonderful engagement we've been having. I'm very happy with the level of engagement we are having. Lots of questions and lots of good questions. So I thank everybody for that. For this last session, this is about, we have been talking about IoT all these past 4 days and focusing purely on IoT, which is one bucket of technologies. It's not one technology, one bucket of technologies. But as I said in the very first introductory session, today no technology is an island. 30 years ago, you could write an entire solution in COBOL or in Fortran or in Pascal with a 50,000 lines of code. Today we don't do that. We write distributed systems. Each system should be as small as possible, right? And you need a host of technology that support each other in that work. Okay. So today what I've brought you are 7 of those emerging technologies. And these are not just any 7 technologies. These are very carefully chosen by us to bring to you. A very special reason for that. I will come to it presently. All right. Before that, so these are the 7 technologies, and this session is about not just talking about what these technologies are, but these are about how these work together, right? And this is a big picture session. This is not a deep dive into technology. This session is what these technologies are doing for us and how these are changing the world around us. All right. Before that, as always, I am starting with a quotation and a picture. So this is something called a law of the instrument, and it says that if you only have a hammer, you tend to see every problem as a nail because that's the only tool you have. So similarly, the only tool we have been looking at so far is IoT, which is a very powerful tool. But at the same time, there are other tools, right? There's a spanner, there's a plier, there's a drill machine, etc., to do other bits of job. Okay. So what are these other tools? These are the 7 tools we'll talk about, and why these seven I will tell you. That there's so many technologies today. There's an entire galaxy of technologies around us, all right, and each day more are added. But from this entire galaxy of technologies, I have brought to you seven very carefully chosen technologies that are not just changing technology world, but that are changing the business world. All right. And what happens is, if you look at any one star, you get a lot of light and nothing more. But when you join the dots between the stars, you get a constellation. And if you have Saptarishi, you have one very important thing. You see the direction. Okay. You'll never get lost. Similarly, these seven technologies are the Saptarishi of technology world today. If you see where these technologies are heading, you will see where the world is heading. All right. So you can see the direction and what we will be doing in the next 10 years. That's why welcome to this session. We call it Saptarishi. This is all about connecting the dots between these ecosystem technologies. All right. Um, there are two objectives in front of us in session. Identify why these technologies and why they are changing the world. And secondly, understand that these are not working in isolation. These are working as a team to solve bigger kind of problems and use cases. Okay. So with that, let's begin. Before we talk technology, let me first share how we decide what technologies to use. Okay, so there's a very popular two words in the industry jargon. One is called a problem space, and one is called a solution space. All right, the discussion always starts from the problem space. The problem space is exactly what is it we are trying to build, without even talking engineering, without talking technologies, without talking solutions. All right, and this is basically why we are here, what we need to do. So there are certain specific questions we ask in the problem space. Okay, for example, the problem might be we need a mobile banking app for banking. No word of technology, no engineering, no software, hardware, IoT, nothing. The problem is we want to give our customers a mobile platform for technology. Or like one of our professors asked in the last one, I want to automate my car at home. This is a purely plain English technology word, because it's very important. That's where the rest of the discussion begins. So as somebody says that if you can articulate the problem well, half the solution is done. All right, so what kind of questions we ask in this problem space? Okay, we ask questions like, what are we trying to do? All right, why are we doing it? Why are we not doing something else? So when you start solving something in the technology world, right, you create this document called a clear choice. In the clear choice, you say this is what we are trying to do. These are the four ways we can do it. And the fifth option is do nothing. Do nothing is always an option in a clear choice. At times that's the best option. Why change something? So all this is happening in the problem space. What are we building? Why are we building? What is the need of this? Sorry. Who is going to use this? All right, and finally, when is it going to be used? So these are all purely problem state technologies. These don't talk about solution or technologies. Okay, and who ask this question? People who are owning businesses, people who are running businesses, etc., etc. And once you frame the problem to be solved properly, you then take the next step, and then you say, now let's see what the solution can be. All right, so once the problem is formed, it goes into the engineering bucket, and practically engineering is just answering the one important question, how we are going to solve the problem. All right, everything else, it is not a small question to solve, it's a pretty big question, but that's the only question we solve in the engineering department. All the other what, why, who, when are coming from the problem space. All right, now here's the thing, right? uh, all the technologies lie in the solution space. Okay, that's the how part. How do you solve a problem? But what happens is sometimes a rare technology becomes so powerful, so useful, so widespread that seeps into, that leaks from the solution space into the problem space, right? A fantastic example from old time is electricity. We don't think of electricity as a solution, right? We have started framing new projects with electricity in mind as a problem space. How do you manage electricity? How do you distribute electricity? How do you conserve electricity? That's not a solution space, that's entirely a problem space. Vehicles, right? Engines, communications, All of those things are technology that became so widespread that they have seeped into the problem space. Okay. Similarly, the technologies, I'm coming to why we have picked these seven. Now, you don't just find engineers talking about artificial intelligence or machine learning or IoT or 5G. We spoke about 5G in the immediately prior session. All right. So you don't just find engineers talking about this stuff. You find business leaders, you find supervisors, you find the shop floor workers using these terminology, which means that they are not just solution space. These are problem space technologies now. You will frame problems using these words. I want an IoT solution for inventory management. I want a machine learning solution for smart vehicles. So these are examples of what is happening. All right. So problem space, solution space. And which is why these seven technologies are technologies today which have seeped already from solution space into the problem space. And when this happens, a very important things happen. Whenever a bunch of technology moves into the problem space, it starts a new revolution. And once again, I'm going to present this slide that I presented in the very first session, but let's look at it from a different angle now. Let's look at it from the angle of technologies that have moved from the solution to the problem space, and that's why this revolution has happened. Industry 1 happened when steam engines became popular parlance. Industry users, leaders started saying we want steam engines. Industry 1 revolution happened. Okay, so electricity got invented. Very nice, Mr. Edison was happy. But when motors, generators, assembly lines became the language of the industry, then industry revolution 2.0 happened. Okay, computers got invented and it took a while for industry to accept it, but when it did become part of the industry, we say industry 3.0 happened. And similarly now with IoT, with machine learning, with computer vision, with 5G, with big data, all of it is now being accepted more and more in the industrial problem space, and we are seeing the rise of industry 4. Right, so every time this has happened in the history, when a chunk of technology becomes part of problem space, you see something big happen, not just in the technology world but in the industrial and social sphere as well. All right, so with this background, let's now take a look at these seven Saptarishi technologies, as we are calling them now. A disclaimer, Saptarishi is not an industry word so far. It's something that we have coined at Copper Cloud. Hopefully it will become more widespread when more and more people realize why these things are so important to use together. All right. So let's start with something which is on everybody's minds these days, AI, artificial intelligence. So I'm clubbing it as three technologies: artificial intelligence, machine learning, and computer vision. All right. So let's start with them. Once again, this is a big picture session. So we will not be doing a deep dive into these technologies. We'll be looking at it from a problem space perspective. What are these technologies? What kind of problems they are solving for us, and who should use them? All right. The how part we'll keep for maybe different workshops. All right. So AI, we'll follow this pattern, we'll define it, and we'll show exactly what it is and how it's different from other technologies. So if you the comment at the top, AI or artificial intelligence is the ability of a computer program to think and learn. And the important word here is not think, the important word here is learn. Okay, because all computer programs think in their own fashion. Okay, but through AI, we don't stop there. We teach a computer program how to think and how to learn what to do next. All right. I'll take some examples to make this concept more clear. So when do we use AI? So many people are confused that AI is just a program. So yeah, that's right. AI is just kind of programs. So when is AI to be used and when is a regular traditional program to be used? So there's a simple answer to it. AI is useful when the number of possible outcomes or the number of options your program has to process is manageable or finite. All right. If your problem sets, if the number of problems, if the number of options you have to compute is infinitely large or unmanageably large, so in that case, it's not possible to write a line of code for each of these options, like 10,000 lines of code. So AI is a better option where in a little bit of code, we don't tell the computer everything. It's like teaching somebody how to ride a bicycle. You tell them the basic principles, they ride, they fall a few times, and then they learn how to ride. So similar thing we are trying to teach to a computer. A good example here is searching for a word in the dictionary. versus recognizing a word that somebody has written with a pen. All right. The first example, dictionary search. Admittedly, it's a very large set. There are thousands of words in the dictionary, but it's a finite set. What the computer is good at is process a large amount of data very fast. Okay. So even if there are thousands of words, it doesn't matter. Your computer will just go through them. So a traditional program can work fine. However, when the program needs to read what is written, so if I'm holding up, I don't know whether it has some writing. Yeah. So if I'm holding up this piece of paper on which I have written something, the way Abhijit writes A is very different from the way Dr. Patil sir writes A, is very different from the way, Professor Indranil writes A. So how does the computer know how many different variants of A are we going to teach it? So that is why it's an infinite problem set. So this is the exact, explicit case where things like machine learning and artificial intelligence are useful. Okay. So this is the primary distinction. We don't teach a machine to think. We teach the machine to learn how to think. Okay. I'll show you a quick example to make this distinction a little more clear. But before that, let me tell you the two kinds of AI that are normally accepted as categories. Okay. The first one, which we started out doing, we as in the broader technology world, is called artificial narrow intelligence. Okay. Or weak AI, it used to be called. Right. What it means is it is not weak by any stretch of the imagination. These are immensely strong programs, but they are focused on solving only one problem. All right, just one problem. A good example in these cases, you will remember back in, I think it was 1990s, the world was woken up to the news that the first time a computer has beaten chess master Gary Kasparov. The computer's name was Deep Blue. All right. So first time ever, Mr. Deep Blue defeated a grandmaster in chess. They played three games. I think two of them the computer won. All right. So this is an example of an extremely powerful artificial intelligence, but all it can do is play chess. It can play it very well, but all it can do is play chess. It can't book tickets for you. It cannot read handwriting. It cannot do computer vision, but it can play chess. So that's an example of a narrow intelligence. Its scope of work is very, very limited, very, very focused. All right. Now we are moving more and more towards what is called a general artificial intelligence, which means it can't do just one thing. It can do a broad range of things, and that gets closer to how a human mind works, how a human intelligence works. Okay. For example, you must have heard of chatbots. Okay, which means you can chat with a computer. Uh, just as a side note, all right, I'll keep that for the next slide. It's much more interesting in the next slide. But another example I can give you is think of when you book a ticket on Make My Trip or Yatra.com, and at 1 o'clock in the morning you remember, hey, I need to make some changes or I forgot my itinerary, and you go and chat with somebody. Now that somebody is not a somebody, but it's a something, because there's a program at the other end of the chatbot. And beginning they were very clumsy, you couldn't understand what they are saying, but over the last 5 years they have become so good that we don't even realize that we are talking to a computer. All right, and just imagine how much difficult this computer's task is. I as a person could write a query in a different way. You as a person could write in a different way. I will make different kind of spelling mistakes, you would make different kind of grammatical mistakes, somebody might write in a local language. So a computer, a general intelligence needs to know what to do with a very wide range of things. Take for example Alexa. Okay, you can see a lot of ads. Interestingly, it's again a very interesting thing to give as an example. In the advertisements, you see, Alexa, switch on my light, and light switches on. Alexa is not going to have hands and legs, right? So there's an IoT component also. But what Alexa does is it converts your speech command into a command computer can understand. That goes through MQTT through the cloud to your bulb as an IoT device and lights up. But as an intelligence, Alexa knows what you want. It remembers your voice. So next time you speak, it doesn't have to ask your name. It remembers your birthday so that it can wish you. So it's a general intelligence. Another example we see every day, if some of you are using Netflix, let's say there are four people in your family, all four of them use Netflix. and Netflix remembers what are the preferences. Abhijit likes, action movies. Abhijit's daughter likes cartoon movies, etc., etc. And it doesn't stop there. It makes suggestions that maybe, Abhijit, you may want to see this movie which is next. So these are examples of general intelligences. Okay. Um, Let me show you an example of, okay, so chessbot versus bot is a good way to remember the difference. Okay. Just as a quick check, is my audio, video, and slides are all okay?
Yes, sir.
All right, perfect.
Yes, sir, it
Thank
is
you.
okay.
Thank you. So let me give you an example. This is admittedly this is a ridiculously simple example, but this is a good example to understand how an AI program differs from a conventional C program or a Java program. All right. So let's say the problem statement is I want a sum of two numbers, A plus B is equal to C. So if you're going to write this in a conventional manner, you pick up any programming language, C, Java, Python, assembly language for all you care, and you will say that this is the program C equal to A plus B. When you feed me A and B, I'm going to do a mathematical operation and give you C. This is conventional programming, okay, finite solution set programming. Okay, if I want to convert this example into a machine learning or an artificial intelligence example, all right, it will look something like this. It will not be C equal to A plus B because we are not teaching the computer to think. We are teaching the computer to learn. All right, and how do we teach the computer to learn? First of all, we create a data set. Okay, there will be three columns A, B, and C. Now we are not telling the computer what is the relationship between these columns. We are letting the computer figure it out. Okay, it will try and figure out all combinations that what is the relationship. We will do some, we'll give it some help obviously, and we will review whether its conclusions are right. But after feeding lots and lots and lots of such numbers, it knows, the computer figures out that whenever you give A and B, C is supposed to be their sum. All right. Then you train the program by giving them even more sets, right? And there's something called guided learning and unguided learning. In guided learning, the computer will keep telling you every time it does a test, hey, you gave me these two numbers, this is the C, is it correct? If it's correct, the computer remembers, okay, I did this right. If it is incorrect, the computer remembers, hey, I made a mistake, so I should do something else. All right. So that is training the program. Okay. And once the program is trained, then it is production ready. It starts doing pattern matching in the real world. So in the example of C equal to A plus B, I'm sure all of you will agree that artificial intelligence is overkill. But this is a pattern. In many, for example, in the handwriting recognition, this is pretty much the only way we can teach a computer to recognize handwritings. Once it can do that, the applications are limitless. Once the computer knows Abhijit writes the 26 alphabets like this, you could give it a whole range of letters I have written, and it will tell you that these three letters are written by Abhijit. Okay, so that's the power. Once you train it, you can use it for any number of powerful applications. So this is generally how AI works. All right. So as I said, first we will define what it is, and then we will define what kind of problem statements it can be used for. Let's take a look at that. Okay. There are many different applications. There are limitless applications. I will probably need one whole week to talk about AI. So I hope all of you have the next 1 week free, right? But let's not do that. In 2 minutes, I will tell you what are the main applications of AI. These are the ones most popular, most visible, okay, most obvious to what is happening around us. Okay, the first one I'll read from left to right. The first one is called NLP. That stands for Natural Language Processing. All right. And this is the kind of thing I said, that when you type out a query in Alexa, it's natural language processing. You are talking it in plain English or Hindi or Marathi or Tamil, and Alexa is going to understand. So it converts spoken word or written word into something that the computer can convert to ASCII text. All right. Alexa is a good example. Now you have gotten this Fire Sticks from Amazon that you connect to TV, and you just say that I want to watch this movie. It converts that into something else. It could be a typed request also. Okay. So all of that is goes under NLP. All right. Now I'm going to connect NLP. I said these things don't work in isolation. Each of these things acts as an enabling technology for another, And down the line, I'm going to talk about sentiment analysis, where I'll try and plug this back in. Okay. So NLP, natural language processing. Then comes the big basket of machine learning. Okay, to be honest, many people think that there's very thin line between AI and machine learning. Almost everything we will do in AI will border on or go deep into machine learning. Okay, machine learning is uh, mostly, it is used for saying taking the computer close to a general artificial intelligence, close to how the human mind works. Okay, and there are lots and lots of exciting projects happening in this space. I would recommend that some of us check out Boston Dynamics websites, because they are building next generation robots. They are using heavily machine learning, deep learning, machine ethics, and training the robots how to manage traffic, how to work in a military application, etc. So I'll share some of these links. Really exciting stuff they are doing. All right. So machine learning is all about deep learning, teaching the computer how to simulate, how to imitate how the human mind works. All right, and endless applications there. The next one is, sorry, I forgot to click. The next one is called computer vision. Now, since this entire workshop is about IoT, computer vision is the part of artificial intelligence that comes closest to IoT. Because remember, the first hallmark of IoT is you're going to have something in the real world which transfers data to something in the virtual world, and all other parts of AI are all virtual. It's bits and bytes, it's files, it's databases, it's pictures, etc. But computer vision is the one thing in which you actually place a camera in the real world and get that feed and analyze that picture in the virtual world, right? And once again, the biggest example that's coming up is security feed. Already people have CCTV cameras in their campuses and factories and offices. You take that, convert it into digitized form, and then take decision based on it. For example, people might no longer, I mean, very way back, people used to sign in attendance, right? If I'm early, I'll sign in green. If I'm late, I'll just have the red pen. I have to sign in red. Then that changed. People got RFID cards. People would swipe the cards, and that will automatically record. Okay. With computer vision systems, I can just walk in the door. There's a camera on top of the door. As I walk in, the computer will recognize, oh, this is Abhijit, he's 5 minutes late, and make an entry in the database. All right. So with computer vision, you don't even have to stop and swipe the card, and obviously any number of applications. Another big example, very popular, is autonomous vehicles, because just imagine what the vehicles have to do. They have to look around them just like people. All right, where is there a stoplight? Where is a zebra crossing? Is that a bicycle on the road? Am I getting too close to another vehicle? All this are, apart from other things, they heavily use computer vision. All right. Even in industrial automation, we are getting many options. So we have been talking about CNC machines, right? Where the owners should say, going back to yesterday's question on consumers, a consumer might say, why are you selling me so many sensors? I have a CNC machine which is already displaying all the data. I just need this data in my database. So that's a ripe example. I think I have some of the devices here as well. My magic box, as always. So you can take, if you can watch my camera for a bit, you can take the smaller version of a Raspberry Pi which supports camera feeds. You can take a very small and economic camera, attach the two, and just attach this mechanically to in front of your CNC screen, and let it read the screen, convert it using computer vision, and transmit it to the database. That's how this thing is gonna work. All right. So computer vision, again, unlimited application. We want to count how many people are sitting. You want to count, see who is here. You want to see how far away that car is. All that is computer vision. Okay, very exciting space. To be honest, in Copper Cloud, we are developing a lot of capability on computer vision these days, because if we have computer vision in our arsenal, a lot of the sensors can be replaced by a camera, and it gives a much nicer experience to the consumer. All right. Right. So after computer vision, you are gonna do what is called sentiment analysis. All right. And this ties back to natural language processing, because as you can see, many companies are paying money to find out what people are talking about them. So when you put a comment, hey, I got a great experience from Tata Motors. Uh, they remove your name, club your feedback with they club it in an anonymous way and share it with Tata. All right, they do if they are paid for it. Somebody says Vodafone is not really good these days, and Vodafone will pay somebody that, okay, what are people talking about me? That's called sentiment analysis. Obviously, where there's good, there's also bad. We had a really big case a few years ago of Cambridge Analytica using Facebook comments and manipulating elections. Or that is nothing but hacking into sentiment analysis. All right. Text to speech, speech to text, we have spoken about. That ties in well with NLP. I'm going to talk about a very interesting field now called machine ethics. Now, machines are getting intelligent, no doubt. That's not new. The new thing is machine ethics. Can machine tell right from wrong in an ethical and moral sense? Okay, which is entirely different, cup of tea. Why this field has come, I will tell you primarily because of more and more robots being deployed in warfare. Okay, because if there's a person, there clearly laid out rules of engagement that you can shoot at the terrorist, but you can't shoot at the terrorist if there's a hostage in front of him. Now, how do robots learn that? Robot will see a terrorist with machine intelligence and just shoot at them. But is it ethical? Is it right when there are other people involved? So there's an entirely new field of machine ethics coming. And this is a very good example of science fiction leading to science. The first mention of machine ethics was by Isaac Asimov in his robots science fiction series, where he laid out the three laws of robotics. And that is the foundation of this new science called machine ethics now. So very interesting how fiction becomes science sometimes, right? So this is about artificial intelligence. Let's look at the next big, before that, this is how a road looks to an automated vehicle through computer vision and machine learning. All right. So very different to how people see the road. All right. So moving on, let's look at the next item. This is data science. Again, very different from other technologies we've spoken of. Let's see what it is. Now, data science is all about extracting valuable insights from data. All right. The keyword here is not data. The keyword here is insights. Data has been there forever, right? We have data lakes, data mining, data warehouses, etc. We want to take out valuable insights from the data. Okay. Um, and let's talk about what is this thing called insight. As I said, let's take IoT devices. Every second, even every few milliseconds, IoT devices are going to generate data. So very soon, yesterday I started, in day before yesterday when we were doing the MySQL thing and Node-RED, I started the Node-RED, spoke to you for 2 minutes. In that 2 minutes, we had 1377 entries. So that's the rate at which even a training system generates data. Okay, all that data we cannot use as people. A small fragment of that data is something we call information. It has some meaning. And a small fraction of that is actionable insight, right? How many times did the power fail? How many times did my autonomous vehicle did not stop at a red light? So that's a very tiny percentage of the entire data, and that's what data science aims to extract and give it to you. All right. Um, there's a data science process behind it. I had a very good experience. I worked as a data scientist for the last 3 years. I was with a large corporate. Now there's a very well-defined process, right? Remember, we are talking about problem space. Okay, so everything starts with the problem statement. Okay, the first step of data science is understand the problem. All right, then collect as much data as you can about the problem. I will share a very good example as the last slide of this session, which will be really very relevant to all of us in this session today. Okay, so I'm going to hold up the example for later. So understand the problem, collect all the data you can collect about the problem, then process the data, filter it. What do we need? What we don't need? What are the trends? Okay, analyze that data. And very importantly, we have seen in the session that Purva conducted for us, visualize the data, because people are not very good at understanding numbers, but people are excellent at recognizing patterns. So visualize this data. You may want a pie chart, you may want a line chart, you may want a heat map, right? Visualize it. And that's not where the job of data scientist ends. The data scientist has to make recommendations based on the analysis. Okay, that's where the problem statement ends. And this is a very exciting field. I'll just share one example. I was leading a team of data scientists in HSBC, and once a year, the head of entire HSBC, the boss of 3 lakhs people, would give a presentation to their worldwide shareholders, and one slide in that presentation would be from my team. Right? There was no other technology team which would feed data into that 100 slide presentation, but our team did. That's how important data science is, because what you do in programming, what you do with algorithms is great, it gets things done. But what is visible, what allows organizations to take decisions is the data dimension. So that's how we do it. As I said, I do have a demo with some very relevant data for you at the end. Let's park that for just like 30 minutes more. Right. So moving forward, what do we use data science for? Once again, I really liked the quote that Atul made and the keynote statement that earlier people used to say data is the new oil, and he has rightly said that it is no longer oil, data is the new water. Okay, because there is nothing for which we don't use data today. So I have just put up the most common use cases here. Databases we are familiar with. We also had a quick taste of it when we did the MySQL thing, because databases have just one purpose: to make data persistent. Now going back to our building blocks, the first building block is embedded. It is doing the sensing. Data is fleeting. It will sense, transmit, and forget it. The next is the communication, MQTT. It's a telephone. It will bring the data to the cloud and then forget it. The cloud might send on and off command, orchestrate, and do all those nice things, switch on a light and forget it. Now all this data is being forgotten. So where do we really use the data? When somebody starts storing it somewhere. That's the whole purpose of a database. Store data, make it permanent. Okay, because as I said before, the only thing which cannot be recovered or repaired or salvaged is data that is not captured or data that is lost. All right. So databases, and that is a very closely linked subject to statistics. To be honest, many people define data science as database plus statistics plus programming. Okay, statistics, we all know there are different measures of measuring tendencies, measuring deviations, measuring bell curves, etc. There's a whole science behind it. All right. To be honest, a lot of the fight on the COVID battlefield right now is happening on the statistics and data science. Okay, apart from the medical fraternity. So we are familiar with how we are using these statistics. Once again, visualization, very fast upcoming stream. So if some of your students are like data science, I would encourage you to, ask them to get into visualization, very fast growing career stream. Okay, all different kinds of things. I said, people are paying for what you visualize. Everything else is infrastructure for them. Okay. Then there is this new term called business intelligence. Now, what is this business intelligence? I'll tell you. All the thing we have seen, database, statistics, visualization, is showing you what is happening now. Business intelligence again is delve into the last 10 years data and find that one nugget of wisdom that, okay, this worked. So how do you figure that out? For that, there are systems called data mining, data warehouses, where this is not like a database where every data gets stored. It is places where trends get stored. Okay, and that goes back many years. Okay, in any case, most organizations worldwide are required by law to keep all the data for a period of 7 years. So they are not going to keep databases for 7 years. It will consume too much cost and memory. They store all that data in business intelligence systems, data warehouses, which are cheaper to maintain, and they store only the relevant bits of data. All right. The next two things probably you would not have heard of. That's very pure hardcore data science. So let me give you one liner on each. Data lineage means data hereditary. For example, all of us have bank accounts, I'm sure. You have your name, your account number, your branch, and then you have another kind of thing called your credit card. Now, whenever you get a statement that credit card number star 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 4384 has been used for a transaction, that 4384 is in some system which does not have your entire credit card, correct? So where is that data coming from? 4384, you can draw a line from that number to the real database where our entire card details are stored, which they don't want anybody else to see. That's called data lineage. Where does this 4384 come from? Okay, similarly, where does your last name get stored? Where does your password get stored? where does something else get stored? This is becoming very important for one reason, that entire world is now getting concerned about data theft. Okay, so for example, every year we used to be audited by the international bodies, not by our employer, but by UN assigned, United Nations assigned bodies, that how well are you managing your data lineage. What that means is, if my account number is stored in X system, who is responsible for it, who is accountable for it, because that system is feeding my account number to 20 other systems. All right, and this is also becoming important because more and more data laws are coming. So in September 2018, on the same day, entire continents of North America and Europe implemented something called data protection regulations, okay, DPRCs. That's why all of you would have got mails that Google would say, please sign our terms and conditions again. Facebook will say, please review, we have made changes to it. Because all these organizations came under a much stricter set of laws, that are you managing your data lineage properly? Are you taking good care of consumers? Okay, so that's all. That's where data lineage, you will hear it more and more. And some of you who already have a background in data science, it will be really good field to study now, right? And the last bit, very exciting stuff called data forensics, which means catching crimes, detecting crimes with data. And just like we say forensics, a department which will come and measure footprints and try and save fingerprints and etc etc. There's a data forensics. Okay, it's a very new field. I'll give you just one example. The most popular, the most visible place where data forensics is used is a place called anti-money laundering systems. All right. So as I said, told you in the whiteboarding session on architecture, AML is a system referred to every time you transfer money, whether it's within India or outside of India. Some AML system is going to use data forensics to look for a signature, that does this transaction look like it could be a fraud or it could be a money laundering. So data forensics is extremely important. Okay, all the stuff we are looking at news these days, that people's past history of WhatsApp messages and all is being reviewed, and drug cartels are being busted. All that falls under this bucket here. Okay, so this is what data science is used for. One thing to be careful about data is, this is a very famous economist called Ronald Coase. He said if you torture the data long enough, it will confess to anything. It's very easy to see patterns that are not there. So you need to get trained, you need to train yourself on disregarding false patterns and false positives. So just one warning out there for everybody who aspires to be a data scientist. All right. Right. I think the next is we have had two sessions already on the cloud, so I'm going to keep this a little short. We had my session in the first day, and we just had a 1.5 hour session with Advait this morning. All right. But in very short, let's call it a summary. Cloud computing is an ecosystem of Internet of Services where both software and computing power are provided on demand. And if you can forget about everything else, you can just think of it as computing on demand. This is the Uber and the Ola and the Meru cab of computing world. You want a ride, you click a few buttons, the ride comes to you. You take a ride, you use it, you pay for only what you use, and you don't pay anymore. All right. Um, what are the benefits? There are many benefits, but the biggest three are: number one, it is universally accessible. So when we go out and do demos to our clients, we don't take computers. I just take my phone. All our IoT products are there on the cloud. Even if I go to, Indore, or I go to Assam, I go to Canada, I go to anywhere, the services will work just the same. That's one of the biggest advantages of putting your stuff on the cloud. You can do a Raspberry Pi, you can do mobile phone, you can deploy on laptop, but a cloud gives you universal access, which nobody else gives you. Second biggest advantage is it auto scales. Suddenly, if you're running a website and you're expecting 20,000 customers all of a sudden, click, 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 3 clicks, you get 20,000 or in 1,000 new machines. All the load goes away, click, 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 load goes away, your servers go away. Okay, so you just pay for what you want. You cannot do it no matter how much money you may have. You can't do that kind of thing with a physical presence of hardware in your office. All right, which is why all startups without exceptions are all going to be on the cloud. To be honest, if cloud wasn't there, many people like us wouldn't be able to start companies today. It will be too expensive. Okay, and that brings me to the third advantage, the expense. Compared to roughly $40,000 a year for a production server, we are paying 20 to 25,000 rupees, which is more than 100 times more economic. These are the three biggest advantages that cloud gives you, and that's what I have written out here. Okay. So many times we get this question that, where do we learn more? There are many resources, but just like IoT, uh, you can start out a million different ways and none of them teaches you what you want. So we are going to start some cloud specific workshops as well. I will keep the group informed when those events happen. Particularly students and ENTC students take the most amount of interest in cloud workshops. That's why we are starting it in the first place. All right. So now Advait used a few words, technical terms this morning about cloud. Let me just expand on them in very simple jargon today. These are the five types of services, four types of services. First four: IaaS, PaaS, SaaS, and microservices. I'll just take one minute to just tell you what it is. IaaS, as I said, Dr. Prakash asked me the first day what is EC2. It is just a server. It is a hardware, maybe a 64-bit processing machine with 8 GB RAM, and it has Ubuntu installed or Linux installed on it. All right, that is IaaS, infrastructure as a service. It is just infrastructure. It has a computer, it has an operating system, it has network, it has security, etc., etc. It doesn't have any of your software. That's called IaaS. Okay, infrastructure only. Then somebody says, why should I have to install my own server? So I want a Node-RED. We have been using Node-RED. You say, give me a server with Node-RED pre-installed. You manage whenever I want new nodes. You manage when the service goes down. You manage the security. So give it to me as a platform. I will just build IoT on top of what you give me. I don't want the hassle of installing servers. So Amazon or any cloud will say, all right, I have taken an EC2. I have installed Node-RED on it. I have installed MQTT on it. I have installed database on it. Now just build your thing. That is called platform as a service because they're giving you ready-made, a base they are giving you. So platform as a service. Then somebody will say, hey, I don't even want to build my applications. So why don't you give me a traffic management solution using IoT? Then they will say, all right, I have an EC2. I deployed all these servers on it. It became a platform. Now I'm going to maybe Advait's company TCS builds a traffic management service, right? You install that service and this is a software as a service. You are not going to write your own software. You're going to use somebody else's software, which is already there. So the whole thing starts with a blank server, which is kind of the least that you can expect. Then somebody says, okay, it's not just a hardware, it's a server based deployed platform as a service. Then somebody says there's a ready-made IoT product. Why are you building your own? Let me install that on the cloud and give you. That's called SaaS, software as a service. And finally, somebody says, why do you even need a service? I will give you part of a service. That's called a microservice. And that is becoming very popular. I'm most familiar with banking examples, so I'll take that. So way back when we used to build banking websites, we would build modules for, balance retrieval, money transfer, change password, etc. Now each of these is a separate service. Maybe Infosys is building a service for money transfer for all banks. So it's going to be a complicated service because every bank will require different things. So Infosys builds a microservice for money transfer. IBM builds a microservice for balance retrieval, and Abhijit Devgirkar builds a microservice for changing your password. So all these three services from three different people are put on the cloud and say use whichever you want. So these are not even services. These are parts of a services. So microservice. And lastly, they say there's something called fog computing, that so far as I said, there's an edge to a cloud. Everything outside of the cloud is has to connect to a cloud. So when you walk in your home, you have a Wi-Fi. By the time you get to your office, you no longer have your Wi-Fi. So you have to connect to a new network. And what they're saying is we extend the edges of a cloud. It's not a cloud that is somewhere in the sky. It's a fog. It's all around you. So when in the home, you use Wi-Fi. When you step outside of your home, you seamlessly connect to your mobile hotspot. When you enter your car, you connect to the car hotspot. When you enter your garage in office, you catch on to the office. So it's like you're moving through the cloud computing. There is no edge. You're living inside the cloud. So that is called fog computing. So these are the five major ways cloud is being used. Let's talk about something not related to software for a change. 5G. All right, and 5G is huge. Everything we have spoken about so far, it's going to hinge on 5G. A lot of the applications we have been talking about, like smart cars, massively connected gaming, military applications, they are going to heavily use 5G. So let's take a look at 5G. 5G is not a new network. 5G is a new kind of network. We are inventing an entirely new philosophy behind communication with 5G. All right, what does it give us? It gives us gigabit speeds. It gives us almost 100% connectivity, and it can connect anything to anything. That's called A to A, anything to anything connectivity. All right, how does it do it? It's a very small visual. There are various different consortium. There's no single body in the world which is inventing 5G. There are many bodies in many countries, private players, which are working on it, but the basic philosophy is the same. I'll not read out all the bits here, but I'll read out the important things. The most important things is the data rates. Okay, so I'm sure many of you would have used dial-up connections, and you tried to download a JPG image, and you would sit in front of the machine for a couple of minutes. It will render line by line. Okay, compare it, today we are watching movies on 4G. That's how big a change was from dial-up to 4G. 4G to 5G is going to be a bigger change. Okay, much bigger than dial-up to 4G. All right, because right from a few Mbps, now we are going to 10,000 Mbps, right? So 10 Gbps or above speeds are going to be possible. That is the biggest visible change. Other things are also there. Primarily, since we are talking about IoT, you are going to have much more bandwidth available. So today it many times happen that especially in homes when we deploy devices, they are deployed 10 devices. We want to deploy two more. So some other device falls off because the network doesn't have so much bandwidth. With 5G, you're going to have 1,000 times more bandwidth. Just imagine a smart city where you have 100 cars on the half a kilometer stretch of road. How much more bandwidth you're going to need to transmit the data second by second or millisecond by millisecond. All right, you are going to need a lot more bandwidth. Okay, and one of other less visible benefits is 90% reduction in energy usage. Why this is important, I will tell you, because this is in the hardware domain. Unfortunately, most people, when they talk about IoT, people tend to focus on software, whereas almost half of IoT happens on the edge, right? So let me take an example. So this is a device, our friend, which we have used many times in these 5 days. What consumes the most amount of energy? I'll tell you. The device that we are using, the Node MCU, when it is not transmitting data, it consumes about 15 milliamperes. When it is transmitting data, it is consuming 120 to 150 milliamperes. So 10 times more data, more energy is being consumed when your device is talking to other things. That is the energy hog. Okay, when it is not talking, it's in sleep mode. It can even go down to microamperes. All right. Why 5G helps is it brings down the amount of energy required to transmit and receive by 90%. So effectively, you're looking at battery lives of 5 years or more. So and 5 years is way more than what people expect the device life to be. So essentially, you'll never have to change the batteries. You'll never have to recharge your devices, and it will just be, this is a monolithic device, sealed device. Don't worry about it. It will work for its entire lifetime. Okay, so that's why it is important for IoT, because we are talking about smart glasses, we are talking about smart clothing, smart vehicles, etc., etc. So even now, when we are building devices for consumers, our biggest bottleneck is we don't want to use batteries. Batteries will run out, customers will forget to change battery, and then they will think that our device has stopped working. So all these challenges goes away when we use less energy for transmissions. All right. All right. Three biggest areas, obviously wherever there's communication, that's going to be affected. The three biggest areas which are looking forward to this is, of course, mobile broadband. Right now, if I'm surfing, I'm watching a new IoT video here, thing gets dropped out once in a while, more so these days. Okay, now you're looking at that not happening anymore. There'll be much more bandwidth available. You could download a lot more content over your same your mobile device than before. Other is mission critical communications, because 5G claims, all these are claims, they are yet to be verified. 5G claims to have 99.999% reliability, as in you'll never have network drops. All right. And lastly, massive IoT, thousands and thousands of devices. We have spoken about M2M. We'll speak about that again in the next slide. Massive IoT connections happening on the same network that you'll have. Okay, so these are the biggest pieces. IoT, I think we have spoken about IoT for 4 days now. But let's do a very quick look at where all it is being used. We looked at it from a technical perspective. Let's look at it from a problem space perspective. So IoT is about integration of information between the real world, between the virtual world, through what are called as things, and integrate things with other things, integrate people with other people. Already started happening. I showed you a showcase here which you could build at home after this workshop. We connected a sensor to the door, and we had some guests here yesterday, business guests, and this was already working. So immediately say, hey, I want this in my home. It's that kind of thing, okay? Because building a website is cool, but doing things in the real world is way more exciting for people, okay? As soon as we opened the door and the light came up, the first reaction was, hey, I want that in my home. All right. So IoT, that's what IoT can do. It can integrate real world with the virtual world. Okay. This is the reason IoT exists. On one side of IoT is the physical world. There are cars, there are keys, there are doors, there are machines, there are phones, etc., etc. There are buttons, and there are animals, because IoT is being used to track cattle in a lot of places. And to be honest, it has started in India also. Gujarat is the first state which has started geo-tagging their cattle. So all cattle are necessarily implanted with an RFID chip in their ear, so that thefts can be controlled and health can be tracked. It's already happened. It's no longer a future plan. All right. And on the other side is all virtual things. There are bits and bytes, there are databases, there are websites, there are apps, there are protocols, etc., etc., etc. And IoT sits with one leg in the physical world and the other in the virtual world. All right. What all is it used for? We have spoken a lot about that, but these are the three most visible things happening. So today, if you go to any good electrical store, Vinay or Anchor or something, there's a big wall on one end. You can try it in your cities anywhere, where they'll give you a remote control, or they'll show you an app and say, sir, you can switch on your light, you can switch on your fan, etc., etc. It's already here. It's not going to happen. It has happened. All right. The other is, and as I keep saying, the biggest contributor to the problem space, the demand, is industrial IoT. This is where the consuming segment comes. In terms of, I think in academics, I think we call it the circuit streams and the non-circuit streams. Circuit streams are electronics, computers, IT, electrical, etc. And everybody else is a non-circuit. So it is this non-circuit verticals, mechanical, civil, aeronautics is going, airlines, big way they're going for IoT for tracking health of the aircraft when it is in flight. All right. So what is the new trend in airlines is that earlier what used to happen is the plane would land, then there'll be a 90 to 120-minute wait where people would review the systems, make sure it is fit for the next flight, then turn it around and it will fly again. Now all that is done before the plane lands. And if there's a problem, people fix that, because it's a very important metric for airlines in terms of their performance. What is their turnaround time? How quickly can a plane land and then can take off again? So they have reduced it from 120 hours to like 30 minutes by transmitting all the data ahead of time using IoT. Okay. Baggage handling. So all of us are used to, that people putting stamps on our baggage and still bags get lost. So airlines have started using tagging of bags using IoT to solve that as well. So it's everywhere. Okay. Um, and very importantly, there's the health sector. So far we have been using Fitbit devices, many of Fitbit or Xiaomi devices, etc. So now there's a lot of applications that can monitor your heart rate, monitor your pulse, monitor your blood sugar, and directly transmit it to your doctor. And this is specially required in cases of heart patients or people who have a history of seizures or epilepsy. So before the event happens, there are signals, and your app, your Fitbit band can alert your doctor that this is likely to happen and we can save lives. All right. So these are some of the most visible. There are many others, but these are some of the most visible applications. All right. What all is IoT used for? Let's take a look at this. IoT is touches, and that's why I kept this IoT. It's not an accident that that circle is in the middle. IoT touches every other thing. And that's why when I train students and faculty in working professionals, I get a lot of working professionals in my workshops who say I am working in an embedded world. I want to upgrade and also work on the software and cloud. And IoT is just the right place for them because once you do IoT, as we have seen, we have touched embedded programming and hardware and sensors. We have touched telecommunications and protocols. As I said, you could do or SMS or Wi-Fi or radio or LoRa. You have touched cloud. You have touched data. You have touched visualizations. So IoT is not just IoT. It's a gateway into all these other things. All right. Particularly, I would like to talk about M2M because we had a bit of a discussion and I may be wrong, but I could sense that there's a bit of a confusion around it. So let me take 2 minutes to answer two questions. And one of them, before M2M, one of this comes very often to me. Every student asks me at least once that, sir, if I don't have internet, is it still IoT? If my device is talking to another device on Bluetooth, if my device is talking to another device on radio, I think I have a device here. So if the can I say I'm still doing IoT because there's no internet? So yes, the answer absolutely, definitely, it is IoT, even if there is no internet. If you look at, the market leaders in IoT, you can go to Farnell's website, you can go to Accenture website, you can go to Honeywell's website. So IoT, they don't define in terms of internet. Yeah, the word has been taken from internet, but as long as you're using internet protocols, right? Bluetooth, Wi-Fi, Zigbee, this is a plain old radio, right? 2.4 gigahertz radio. As long as, see, the principle is important. If you have connected things, exchanging data with other things and with humans, it is IoT. Rest assured on that. All right. Then we come to M2M. So I think there was a bit of a confusion because in the past, M2M was only limited to what are called PLCs and FPGA systems. Okay, field programmable logic arrays and programmable logic controllers. These are not new devices. They have been used for the past 20-25 years. Any old existing manufacturing plants which have huge assembly lines are using PLCs. One PLC system, a system with just one PLC would cost you upwards of 1 lakh. And if you have 30 PLCs deployed, you can just imagine the cost. Okay. So in the beginning, M2M was limited to things like if you are doing PLC and FPGA, yes, you are doing M2M. But what has happened is with the advent of IoT becoming so easily available and so cheap, these systems, M2M is no longer now disjointed from IoT. It's an extension of IoT. So because your factories are not always going to be in one place. For example, I'll tell you, one of our clients, they're serving Maruti. The Maruti headquarter in Gurgaon has a dashboard, has some machines that are responding to what is happening to my client's factory in Pune. Okay, that is M2M, no people are involved, but all that is happening over MQTT and cloud. So it's very much, it does use IoT technologies. So I just hope, I thought there was some confusion. So I thought I'll take 2 minutes to resolve it. So even if you don't have internet, as long as you have connected devices talking to each other, doing something useful, it is IoT. Even if your factories are far away and your machine in factory one is talking to machine in factory two over MQTT and IP addresses, it is still M2M. All right, I'll forward some articles on this front to you. So that's what IoT does for us. No end to uses. Next part is very useful and it is very interesting because it comes out of gaming. All right, it's called AR, VR, augmented reality and virtual reality. You must have heard this word. Sometimes we don't know the difference between the two. So virtual reality is an immersive experience in which we wipe out the real world from our eyes. We can, wear VR goggles and we get immersed into an imaginary world. it could be a game, it could be an educational experience, it could be a training program, etc. So we don't see what is in front of us, we just see what the computer is showing us. Remember the matrix, right? So this is virtual reality. It started with games. To be honest, a lot of good technology have started with games. So probably all of us should be playing more games. As a side note, the international gaming industry is bigger in terms of money than the international film industry. Okay, they make more money than all the films combined every year. So this is where the virtual reality started. You forget that you're in the real world. You are transported in a way into an entirely virtual and imaginary environment where it's not just about seeing things. You can hear things in the virtual world. You can feel things. You can wear gloves. They are called pressure sensors. Okay, it's called pressure feedback. So if I'm holding an object here in the virtual world, I will still feel the pressure of that object in my hand through the VR gloves. Okay, entirely immersive experience, beautiful experience. All right. So this is called virtual reality. It started with gaming, but these days virtual reality is also used to train our medical professionals for surgeries and all. All right. So it's no longer limited to gaming. It's used for some very, very serious training as well. All right. Let's talk about augmented reality. Now in virtual reality, we saw that we wear a goggle and the world disappears and you are transported into a virtual world. Augmented reality, thankfully, does not delete the real world. It keeps the real world in front of you and it overlays virtual elements in front of us. So a while ago, I'm sure you will remember that there was this game everybody was crazy about. I forgot its name. Pokemon, no, not Pokemon. There were these cartoon characters on the road in front of you and you have to chase and catch them, right? So what that means is the road did not disappear. You could see what is there in the real world. There's a road, there's a car, there's your hand, there's a person. But on top of that, you will see a virtual element which is not there in the real world. Okay, and then you can run after it. So it's a superimposition of virtual elements onto a real world. Okay, and one of the most popular example of here and very, very visible example, it started out with Google glasses probably 5, 6 years ago, that they had put a small microchip and Wi-Fi chip on your glass. And what happened is this glass is connected to your Facebook account. And if you are walking across the street and your friend walks in front of you, the glass will recognize the face and say, hey, your friend is coming over. This is their birthday, or today is their birthday. Did you wish them? And the last time you interacted with this person was 2 weeks ago. So it superimposes those text elements on your glass. So that's the kind of virtual reality. Okay. It is being used more and more for assisted services also, city planning, smart cities we are saying. So let's say we'll have metros in a while, maybe sometimes one metro station is closed. So hypothetically, if you're wearing a Google Glass or a Geo Glass, Geo has come up with the same context a few months ago. Just before you start walking the stairs, you'll get an alert that, my friend, this service is closed. Why don't you use another exit? So things like that. You could use it for bus stops, that when is the next bus coming, right? All the kind of thing. Now, obviously, we'll have to take care that the people will sit in exams and we have to have blocking services also. Otherwise, they'll be seeing their textbooks while they are writing their exams, right? So this is your assisted services. Now, a very serious application of this is trainings, uh, particularly military trainings, right? So you train Air Force pilots. To a small extent, I visited a military training facility in Secunderabad a few years ago. So the drivers of the trucks and drivers of the tanks were first trained on augmented reality systems first. So you can see the world and you can target the targets and fire the shots before you have to actually give them any real hardware. All right. And once the augmented reality training was over, then you would trust them with the real weapon systems, etc. So very, very popular for all these things. So that's augmented reality. You augment reality, you add more stuff with it. All right. Different elements where we are using it. First and foremost, entertainment. Started with games. Now you're having 4D movie experiences where you can move around. Okay. I think I should have let me show. If I can find a particular URL, I'll be happy to show you that. But in the meantime, we will continue.
Share it later on.
Yeah, I will share this later on. It's a very good weather channel, weather.com has started this augmented reality experience in weather reports. So I'm looking for that one. So give me just 10 seconds. I'll see if it easily comes up. Otherwise, we'll move on. We want weather.com AR. Let's search for that. I'm just searching it on my desktop, so you won't see it here. While it loads, we will move on. All right. So it's used for entertainment. It's used for education. And I think 1 year ago, I saw the first report of this happening when there was a college. I'm not sure which college it was. It was a college in the UK which was using AR to teach history. So you could actually walk, the streets of Rome and ancient Egypt and interact with the people in that setting, etc., etc., etc. So really powerful, and people would never forget what they're learning if we taught them that way. All right. All kinds of professional training, right, from medical training to paramedics to military trainings of all sorts, and assisted activities. There'll be people who'd be visually impaired, so you can feed to them in their ear what's in front of them. Assisted living in cities, that this exit is blocked or this is one way, etc., etc. So all these are very popular uses of AR VR. Okay. Right. Now, the last one I have kept, you would have heard this word a lot. It's called, it's called blockchain. You would have thought of it as Bitcoin because that's the most visible part, right? But blockchain is not Bitcoin. Bitcoin is just one of the uses of blockchain. Blockchain is all about trust. All right. Whenever there are two parties and they have no reason to trust each other, just like when we are doing banking transaction, we use bank as a escrow. I trust the bank, you trust the bank, so let's both trust the bank and do a transaction through it. Similarly, blockchain is all about trust. Wherever there's an element of trust, there's payments, there is supply chains. I have sent you material, have you received it or not? There is elections. Now there's a big news around about mail elections and all, but this discussion is not new. At least for 10 years, even India has been discussing, can we conduct elections in an electronic way? So if and when that happens, I can guarantee you that blockchain will have a big role to play in securing those elections. All right. We talk about biometrics when we swipe our thumb. Aadhaar card, our thumb, our irises, our face, all of that is stored somewhere. Who validates that this is the right metric? It's done through blockchain. Okay. So let's see how blockchain works. It's a very simple fundamental. It's called a distributed ledger technology. The name comes from the banking world. Okay, I'll tell you what it means. Let's say there are six people sitting around a table, and person A transfers 1,000 rupees to person B. Now the whole point of trust is person B should not be able to say I never received the money. Okay, so what happens is person A transfers money to person B, and that transaction gets recorded not just with A and B, but with everybody sitting around the table. This is called a distributed ledgers. Ledger means a register. Everybody's register, everybody's notebook gets updated by saying A has transferred 1,000 rupees to B. So if there's a conflict or a confusion afterwards, you will ask all of the above. What does your register say? Was the money transferred or not transferred? And everybody will say, yes, I've recorded money was transferred. This is the funda behind blockchain. There's nothing more. The implementation, of course, is extremely complicated, but fortunately, this is not a how session. This is a what, why, and when session. So we'll not be going into implementation, but this is what it is about. Why the name distributed ledger came is I've put up a new image there. The left, the central image is of a banking system as they used to work earlier. All banks would exchange each other's checks throughout the day, and at the end they would come at every day they would come to a place called a clearing house where somebody says, hey, I have your check, you need to pay me this much, etc., etc. They will exchange checks, and a central register would be kept that who owes how much to who else. And if somebody hacks that register, somebody steals that register, somebody destroys that register, then that is valuable information lost. So that got changed to something called distributed ledgers electronically. Now everybody involved in the banking system, whether you are involved in that particular transaction or not, will have a record of that transaction. All right. So that information will never be lost. Now, there's a common confusion says, so everybody can see my transaction. So how will it be private? How will it be secure? Because when I say everybody, these are not people. People cannot see your transactions, but the blockchain algorithm deployed on everybody's phone or everybody's desktop involved in that network stores it securely. No person can see that data, even if they want to, but the system knows that the transaction has happened. All right. So this is why this is still secure. What all ways you can use this? Four biggest ways are firstly electronic money. Bitcoin is the biggest money. So yesterday's rate was one Bitcoin was equal to $19,200. One Bitcoin, right? Then the second most popular currency is Ethereum currency, and there are many, many more. So all of these track the value of the money using blockchain. All right. Then there comes digital identity. If you're going to work from home now onwards, how do you know that you are working or not working? How do you know that this is the person who has swiped their thumbprint? So once Aadhaar came, right, you will remember that the Supreme Court ruled that you can no longer keep people's photos. So Aadhaar made a change. From that point onward, if you're going to buy a SIM card, the shopkeeper tells you stand still and blink your eyes a few times, because the camera detects whether this is a live person there or I'm showing somebody else's photograph. So blinking the eyes, this is a good use of computer vision as well as blockchain. So that's how the technologies complement each other. All right. So digital identity, supply chain management, the huge supply chains operating across the world, what has been shipped, what has been paid for, what has been invoiced, a lot of that will eventually move on to blockchain. All right. And lastly, electronic voting. Sooner or later, this has to happen, but this has to happen with the right safeguards. And so far, blockchain seems to be the only technology that can support this kind of use case. All right. So I think we have covered our 7 stars, connected the dots between them to an extent. We have seen how CV supports blockchain. We have seen how NLP supports sentiment analysis. We have seen how IoT is supported by all of these together. Now let's take two very simple examples before we end of how these things work together as a teamwork. And the first, I think this is a brilliant example and very relevant because the entire world is familiar with autonomous vehicles now. India has made us start with e-vehicles, electric vehicles, because that's the first step before we move on to autonomous vehicles. So this is an example where this is thing called confluence of technologies, where all technologies flow together into the solution. So let's take an example of a smart city, maybe 8 to 10 years from today, where you will have a lot of smart things on the road. Okay, and there's a beautiful example of how these things work together. I will show you a bigger picture. So what all do we see here? There are smart vehicles that are interacting with other smart vehicles, okay, to follow the road rules. The smart vehicle is interacting with the road itself, that the road will be saying that, there's a zebra crossing here, there's a traffic light here, this is a one way here. So the car is interacting with the road infrastructure. That's called V to I, V vehicle to infrastructure. V to V is vehicle to vehicle. So very recently there was a very popular case where a Volkswagen autonomous vehicle and a Google car almost collided because the Google car was entering a highway and the Volkswagen was on the highway. So the rule said that whoever is entering the highway should get precedence on that lane. So the Volkswagen car stopped, allowed the Google car to go on, and there were no drivers involved. Okay, so that's what we mean by vehicle to vehicle interactions. All right. Vehicle to roadside unit, traffic lights, speedometers, people standing, etc. And vehicle to pedestrian. Is there a cycle here? Is there a pedestrian here? For India, I think we have to put special intelligence that is there a cow sitting on the road also, right? Or is there a dog crossing the road, etc., etc. So as I said, India is a special case where Tesla and bullock cart share the same road. So the solutions have to be very unique. So this is a beautiful example. It's called V2X, vehicle to anything communication. And the only bit we have left here is AR, VR and data. So obviously all of this is generating a lot of data which will be analyzed. That what is the performance of the car, and constantly that data will be fed back to the server. And cars, remember, these are AI systems, these are capable of learning. So whatever the intelligence they had when they left the factory, they're going to learn how to become better cars every second on the road. Okay, that's data. And you can bring in an AR VR perspective that maybe we'll start training drivers, if at all there are drivers, through AR VR technologies in the future. All right. So this is a confluence of technologies. One technology can do a lot, but all of them together can create things like smart cities together, right? The other example I'm going to show you, okay, so this is the tags, this is IoT, that's AI or computer vision. Knowing the rules of the road, how do you teach the rules of the road to a car? That's deep learning, machine learning, right? 5G, so many cars on the road, how will they talk to each other? They need high bandwidth and reliable communication, 5G. And data science for analysis. All right. Let's take one more example from Industry 4. You have this smart shop floor, lot of different. So we spoke about homogeneous machines and heterogeneous machines. So these are going to be heterogeneous machines. Not all the machines are going to do the same job. So you are going to have smart scanners, right? QR code scanners or RFID scanners through IoT. They are going to be interacting with your forklifts, that the forklifts don't collide with boxes, forklifts don't collide with people through artificial intelligence and computer vision. You are going to do quality controls through deep learning. So you'll have a box, yesterday I saw a video that, all your boxes were coming on an assembly line, and any box which did not have the sufficient metrics was, shoved off by an arm that kept moving. So all that was being driven by a self-learning system. All right. You're going to have 5G to connect all these things, right? There has to be a connection framework there, right? So these are some of the examples in blockchain for inventory management or supply chain management. So these two examples are really good. We can relate to them. We can imagine what they will look like. And this is not too far off in the future. They'll be here in 5 to 10 years. In fact, we are contributing to build this out in MSME sector. All right. So I think we are coming to the end of this session. I promised you when we spoke about data science that I have a very good example, and that's a really good note, not just to end this session, but also to end this FDP on. So I'll take 2 minutes to walk you through this data science example. Okay, so we said the thing starts with uh, collect the data, analyze the data, visualize the data, and make recommendations. So let's follow this 5 step very quickly. So this I have pulled this from a business magazine. The text is too small, so I will tell you what it says. Now this is analysis of artificial intelligence researchers, and see all these 7 technologies. They have pretty much the same kind of intellectual power behind them. Same kind of people do this work. Same opportunities exist. So instead of IoT, let's look at AI. So this analysis from uh, I think oral presentations at Neuro IPS 2020. That's what the slide says. So what they said is they said let's see where do most of the top 0.5%, top 0.5% of half of 1% of the top AI brains in the world. Where do they study? Where do they become AI expert? And where are they working? Top 0.5%. All right. So they found some of this. The visualization is a very small thing. So what I'll do, just like when somebody gives you an X-ray, we don't look at X-ray. So we look at the interpretations. All right. So what we found in the interpretation is where does India stand here? We are the second largest slice when it comes to where these people are born. Okay, where are they from? Where do they do their basic graduation? Second number in the world. Okay, the first is US. Then where do these people learn AI? Okay, we are number 4 there. There's US, there is China, there is one more I think here. Let me see what that third slice is. The biggest is China, the second is US, the third is Europe, and India is at number 4. 8% researchers learn their skills in India. All right. And where are we when it comes to where these people work? We are nowhere on the chart. Okay, so we are not even the 10th person on the chart as to where do these top AI researchers work. Okay, so in short, let me rephrase it in the data science interpretation. We have the raw material, okay, but we need to do more processing properly and we need to deploy that product properly here so that we can be in the top 5 or top 10 somewhere. Okay, clearly all of us I'm sure would agree that we should solve this. All right, so this is the problem. This is the analysis. This is the data. If we don't have data, we would never know the problem exists, right? What can we do about it? there is a role for you as the faculty community representing institutes and university, and there's a role for people like me who have either corporates or startups or some way connected to the industry, right? So let me just give you the recommendations. The final step as a data scientist, we need more and more R&D opportunities passing off from industries to the universities. All right. I'm glad to say this is already happening. Just past week, we have had two engagements where university professors or PhD students are trying to do more of this research, and we are helping them with that. We want universities to become centers of excellence in one of these seven technologies, because today people come to a university and figure out, oh, here I can learn artificial intelligence. What we would like, not just we, what we as a technology community would like is people come to the university because it has a center of excellence in AI, and that is going to happen very soon. All right. Make more and more education opportunities, make more and more projects available. And a good start has been made by AICTE in the beginning of 2019 here. They have allowed us to run vocational courses in these seven, plus they are calling it future skills. If somebody is interested, I have the entire white paper for that. I can share it with whoever is interested. But it's a matter of pride for me to share with you that the very first grant we have received to run a degree course in IoT has been given to us in partnership with a university, with the Amravati University. The very first BSc degree in IoT that we have started running, and this BVOC, a Bachelor of Vocation in IoT. And similar things are happening for AI, data science, and all these kind of things. All right. So it's already started happening, but it needs that critical mass for us to really, give it the momentum it needs. Right. And finally, we have to partner. Industry and academia have to partner, and that's what I'm very happy when Dr. Patil sir shared that we have crossed the 1 lakh mark, right? And just imagine if we start a wave, how fast that wave will travel. We have to create more training opportunities and more partnerships between entrepreneurs and universities to make it happen, right? So I'm very happy that I think yesterday a lot of our audience, at least 4 or 5 of our audience contacted us that we would like to do more, and I thank everybody for that. And we need your support for this, because together we have been able, just by us, we have been able to train 4,000 students and 600 faculty in 3 years. With everybody's support, let's ramp this up. Let's get more and more people. And I looked at the registration sheet yesterday. There are a lot of folks from mechanical, civil, aeronautics background with us today. Do help us. We want to partner with you to raise this 7% so that it competes with the circuitry streams, and that's when demand will be there. If there is demand, we will have jobs here. So we will not be nowhere on the pie chart. We will be at least in the top 5 people if we can create the right jobs here, right? It has started. We are getting a lot of response from universities and professors like yourselves. But my urge is, this is a great platform for us to find more such partnership opportunities and bring these skills to our students, so that we are not number 20, we are number 3 or number 5 on that pie chart. All right. As a data scientist, this is my recommendation. All right. So with that, I think we have come to the end of this session. I opened this session with a quote about the law of instruments. At the end, this is what Arthur C. Clarke, one of the greatest names in science fiction, said, that any sufficiently advanced technology is indistinguishable from magic. All right. And although it doesn't look like it to us because we are all technologists, to the rest of the world, the layman crowd, all these technologies are magic, and we have it at our fingertips. And who's going to get this to everybody else? It's going to be our catalysts. It's going to be us. Picking up from yesterday, we spoke about how can we motivate. I'm sure you have all identified your catalysts by now, right? So let's push this forward. I got a couple of requests yesterday. Can we speak to your students about how to be a catalyst? We'll be happy to do that. We consider it our national duty to come and talk to your students about how to be a good catalyst, because these seven technologies are magic, and this magic is in our fingertips. And let's bring it to the rest of the world. So with that, I'll thank you for attending and being a wonderful audience. Open the floor for questions before Patil sir for closing ceremonies. Any questions for me?
Hello. Yeah. Any questions from audience?
Hello.
Yes,
Hello.
sir.
Abhijit sir, good afternoon.
Good afternoon. Please ask the question.
Yeah. Just so any emerging research topic on a topic on IoT or cloud computing or AI.
Hello, Abhijit, can you listen? Hello.
Hello. Hello, Abhijit sir, audible?
I think Abhijit has lost his connection. He's lost his audio.
Okay, sir, not an issue. I will ask on.
Yes, you can ask this
Yeah,
question.
yeah. I can ask, sir. I can ask.
Yes. Okay. Anyone else? Okay. We have already run out of time for this particular session. So what we will do is we will start with the valedictory session straight away. So we have come to the end of this FDP, and for the last 14 sessions we have discussed different aspects of Internet of Things, and our effort was to give you some industrial perspective of Internet of Things and the hands-on practical approach to IoT, as well as to touch upon the various emerging areas which are touching IoT or part of IoT already. So I hope you must have enjoyed this session, and now I request the 2 to 3 participants to say a few things about this FDP. Anyone can.
Yes. Sir, this is Chamundeshwari from SSN Engineering College, Chennai.
Yes, madam.
It was a good walkthrough for all of us. I feel that we had input related to the IoT.
You can switch on your camera.
Here, my PC, I'm connected to my PC. It is not, I don't have a camera attached here. Okay. So it was a good experience connecting with all the industry experts and academicians with so much of participant was there, and it was a pressure for us to study about this IoT sessions, to learn about it. It was. I have to thank the organizers for organizing such an event. It was really good, and we had a good time. And because so many participants, with so much participants, you would have made lot of. You would have spent a lot of time and how to arrange things correctly so that the technology gap should not be there, so that everyone should be able to listen to the various sessions. So I first thank the organizer, and also I thank Abhijit sir, who was throughout the session from the day one onwards along with us. He was pouring in all this IoT experience to us to learn the concepts what he has experienced. So, and also all the other, on the behalf of all the participants, I thank the organizer and the people who did a good task here in organizing this. Thank you, sir.
Thank you, madam. Thank you very much.
Much,
Any other
ma'am. Sir, Abhijit, I'm back on the mobile phone. I've joined.
Yes, Abhijit, we have started with participants' feedback.
Sure, sir. Thank you very much.
Yes, please. Any other participants wants to say something? I think Anirban sir wants to say something, but his audio is not working. Your audio is not working.
Hello, sir.
Yeah, now it is. Yes, please.
This is Karthik Patel, sir.
Okay, please.
Yeah, sir. I want to thank first of all Abhijit sir and the entire team, Pooja ma'am, Yogesh sir, to get in the insight of the complete IoT blocks. Especially what I like here is the way in which the complete FDP was planned, and especially what I like is that building blocks of the IoT that sir has started from the embedded programming, then followed by communication, then we have orchestration, then data, and then visualization. So the complete IoT building block that was explained in this program, and that was very much enthusiastic and interesting for us to dive in. And definitely force our students to get into this field, whatever the projects which we are guiding for the PG student, PhD students, or like that. And the concluding session of the 7 enabling technologies was very enriching. And it is like a triggering that we should definitely dive into this field and do something for this society, because everything what we are learning here is betterment for this society. And then I would like to thank the principal of the Army Institute of Technology, Dr. BP Patil sir, the HOD Electronics and Telecommunication, Gajanan Patil sir, and the entire organizing team, Rajashri ma'am and the entire organizing team. For such a wonderful organization of the FDP, and especially you, sir, for patientfully replying our messages on the WhatsApp, and getting in touch with us throughout the FDP. Yeah, thank you, sir. Thank you.
Thank you, Karthik. Yes. One more.
Hello.
Yes, sir.
Yeah, good afternoon, sir.
Good afternoon.
Yeah, just I have a word. It's the very knowledgeable FDP program, sir, and we learned a lot. And Patil sir, Dr. Patil sir, you give me you gave a reply to all the students on not only in office time, in apart from off time like 8 p.m. or 9 p.m. and whatever. And Abhijit sir taught lots in IoT, Internet of Things, in a practical way. Not only practical way in how to organize in a company and how to design a circuit, and lots of things they taught to us. And lots of thanks, sir. It's a very knowledgeable, sir.
Thank you, sir. Thank you very much.
Okay.
So, with this, I will propose vote of thanks. So we have come to the end of this FDP, and before that, one request for all of you to whoever has got the cameras, please switch on your camera so that we can take one snap, the maximum participants as we can. So please switch on your cameras. Those
Right now, sir?
Yes.
Yeah, right now.
Yes. All of
Okay,
you, please,
okay.
so that we can take a snap. Renuka
Okay,
madam,
sir.
are you ready?
Share,
Yeah.
can share the feedback link on the group.
Yes. I will. I have shared the feedback link on the group already. But
Give us, can
you
you
have to go to
share,
ATAL website to check
it
the
again?
feedback. No, the feedback, the main feedback which is necessary for certification is the feedback on AICT website. So you have to go to this ATAL portal and log in with your login ID which you have created while registering in this FDP. So log into AICT ATAL page, then go to login. Don't log into web portal. You log into there is a login tab. Go there and log in onto the ATAL portal.
Okay, sir.
Renuka madam, are you ready?
Yes, sir. Abhijit, sir, are you there?
Yes, he is there.
No,
Abhijit, are you there?
he has to stop
Yeah,
sharing his screen actually.
Yes,
Acha. Abhijit, please stop sharing the screen.
Oh, yeah. Actually, I've already stopped, but somehow that network seems to have been stuck. I'm just shutting down my machine, so it will go away then.
Okay.
So my machine is connected from the net now.
Okay, now we can take it. Okay.
Yeah.
Yes, in one shot, I'm taking. Danish, sir, please adjust your camera. Vinay, sir. Yes, I'm taking picture. First picture.
And while ma'am is
Done, ma'am?
Yes. Now,
while
one second.
taking a picture, I would like to really thank everybody for being such a great audience and asking such great questions because we love
Thank you
answering.
very much, sir.
And I would then like to thank the entire organizing committee in AIT because this was one of the most flawless, most smoothly executed, a series of workshops we had. Thank you very much, Arthur sir and the team. And last but not least, my thanks my team here who has always been working. So many people have congratulated us for the hands-on and all, but I'm just the guy presenting the demos. I have Yogesh and Purva and other folks supporting me on the back end, creating all those things so they work well for the demo. So my thanks to them as well.
Thank you, Abhijit. Thank you very much.
Yes, sir. Now, for second slot, please, these people can switch off their camera and others will come into picture. That
So those who had switched on, please switch off their camera so that
and now,
others
yes.
will also come into picture. So in the meantime, I will propose this vote of thanks. First of all, I would like to thank AICT for giving us this opportunity to organize this workshop, the FDP. They have given us full support in terms of money as well as providing the web portal for participants to join. Then I would like to thank the management of AIT, our director, Brigadier Abhay Bhatt, who is constantly supporting us for organizing such workshops. Then I would like to thank our principal, Dr. P.P. Patil, who is encouraging us to organize such workshop and supporting us in every way. Then I would also like to thank the entire team of ENTC department for giving us the full support. There are a few participants in the department which I would like to specially mention: Dr. Renuka Mandari, Professor Jitendra Chave, and Vijay Karwa. So they are all participating as well as helping in organizing this workshop. Then special thanks to Rajeshri, who is constantly with us, providing the technical support, creating links, etc. for this workshop. And then special thanks to Abhijit and his team, Urva, Yogesh, and Madhusudan for organizing and giving wonderful sessions, delivering wonderful sessions during this workshop, this FDP. So thank you, Abhijit. Special thanks to you as well. And last but not the least, the audience. You were a wonderful audience, and your support was also overwhelming. And I enjoyed a lot with your messages and queries, etc. So thank you very much. So thank you all. So I hope you must have also enjoyed this, and let us see in future we can meet again in person or maybe online sometime. Thank you very much. So
Sure.
yes, so please complete the three formalities. First is the quiz that we have circulated. Second is the today's feedback which we have circulated on forms. And the third one is the feedback that you have to fill on the ATAL website. So thank you very much. So if you have any queries, you can always contact us on the WhatsApp group, which is always active here. Okay, we'll be very happy to help you all. Thank you. Thank you very much.
Thank
So
you.
with this, we will end this FDP.
Thanks a lot.
Thank you,
Sir.
sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you to all the department and
Thank
the
you.
participants.
So today's feedback link is shared.